Hi, I want to start with the string lecture. Uh, Whenever you think of strings, you should just think of text, like letters of the alphabet, but of course it can contain more than just letters of the alphabet. It can contain numbers or anything that you can produce from your keyboard. So let's look at some examples here. Actually, strings will be in double quotes as we have here. So like, for example, here's hello, that is a string. And we put it into this constant variable called greeting. We can actually also have numbers in our string. So you can have a string of numbers, 1, 2, 3, and that is assigned in numbers here. So let's go back here. Let's get rid of most of what is default here in the Swift compiler. This here is also a string. This little guy right here is a Unicode variable, a Unicode character, I mean. I'm not sure exactly what it is. For this, I actually consider that to be like an advanced feature, something that's beyond the scope of this class, but I just want you to know that it's possible to create characters that are not necessarily the ones that you see on your keyboard, that you can produce other characters as well. So let's look at a few of these examples here that we have in the that we start off here in the notes. So here we go. Let's go ahead and add these in here. So we have these two variables. One thing I want to note is that if you see these tick marks here like this, that's going to be, I believe, invalid. Let's try to run that and let's see what type of error is produced. I'm going to leave those in there on purpose. The reason why is it's very common for people. Quite often Word will produce double tick marks that look like this, and most compilers don't like those. Like, for example, the Swift compiler here says Unicode curly quote found replaced with normal characters. So let me put a print statement down here for you that we also get the error whenever we do that. See, now let's go in and let's replace this with the double quote, which is the double quote that's right next to your enter key. So you hold down shift. Notice how this one's different than the other one. The other ones have kind of a slant on it. This one, the double tick, it goes straight up and down. So now if we run this, it compiles and it prints out hello. Of course, it doesn't print out numbers because we don't tell it to print out numbers. But we could do that as well if we'd like. Let it run, see what happens. Of course, you could put these on the same line if you'd like. You don't necessarily have to be on the, in the same print. They can be in the same print statement. So as you can see here, I'm playing around with this stuff a little bit, seeing what works, what doesn't work. You can change these a little bit. Notice I put a space right there. If I run this, it's going to then put a space right here. So it's possible to do that if you'd like. So like I said in the last lecture, the best way for you to learn these compilers is to play around with different things, see what works, see what doesn't work. So those are strings. Every once in a while you want to work with characters, and all that a character is it's just a single like letter, something like that. So we could have that as well down here. If you don't specify this, you don't, these here are going to be strings. Even if you do this, this is still going to be a string. Later on, I may show you exactly how to figure out what the types are, but right now, I won't worry about that. this is still considered a string even though it contains one character. If you want to specify that the variable that you're defining is a character, you have to put character as the type here after the colon, like what we have here. This last one here is invalid because a character can only contain one letter in it, and this contains 3. So this is going to produce an error. So let me get rid of this stuff up here. Sometimes it's better to get rid of extra stuff and then just be able to look at a few lines of code to help simplify things. First off, let's comment this out and let's just print char, a CHR, and see that it executes okay. All right, it does. Now let's see what happens whenever we go ahead and put in this CHR3, char3. It should produce an error. Yes, it does. It says cannot convert value of type string to specific type character. And what it's saying is that you've got too many characters in here. A character can only contain one, like letter or number, something like that. It cannot contain more than one. So one way to fix that would be to do something like this and run it. And you notice that now it compiles. All right. So you may want to play around with that a little bit, see how that works. If you have any issues with that, try some of your own examples. Another thing that we like to look at is the length of a string, for example. So this is something that's useful at times. Like, for example, if you're writing a program to make sure that a password is big enough, has enough characters in it. You know, that if you only got 2 or 3 characters in a password, it's easy for somebody to guess. But if you expect it to be 8, 10, 12 characters long, it's harder to guess what it is. And so one of the things that we can do is if we had like a password or something, we could check to see how many characters it is. In Swift, we would use .count to tell us what that is. So let's get rid of some of these here, and let's just look at this example. This should output a value of 4 because we got 1, 2, 3, 4 characters here. Okay, see, we got 4. You can also add spaces in here, and that counts as a character too, even though you don't see anything. It takes up space, so it counts it. You know, you could add stuff at the beginning or at the end, and as this is still a string, it counts out how many places are there, and it displays that. So think of your own string. Maybe you put in your name here. I'll put in my name. That's 5 characters long, and it should return 5. So maybe that's an exercise for you to put your name in there, maybe your full name, and see what happens. Okay, moving along. We kind of do that in this example, but I want to go ahead and show you. Of course, right now we're doing straight off of a string. Let me a Billy.count. Notice that this we call this hard coding whenever you put in a value like this that you can see. And here in this example, we're putting in putting the string Billy in this variable called myString, and then we check to see what's displayed. Let's do the same thing here. And what should get displayed here is 3 different values. The first one will be the count of Billy, which is 5, because there's 5 characters in Billy's name. This second example shows you what is displayed when it's in a variable. So this is still a string, and it will print out, it should also print out the value of 5. And here's an example. Notice that we got these weird tick marks. So if you copy and paste it like I did, you'll have to replace these. And then it's going to print out John, this is a constant where this is a variable. Remember, let defines constants and var defines a variable. And then we print out the name, which in this case is John, the count of how many characters and the length of it. So let's see what's displayed. Okay, so like I said, we got 5, 5, and then 4. If you want, play around with this. Try different things here. Try adding, taking letters away, changing some of these, see what happens. The point here that we're trying to make is that you could hard code something like this and have it print out a value as a string like this, hard coded as a string, or you could have that string being a variable and be able to use the count property as well. Like here's another example of doing that. So going back to our lecture notes, sometimes we want to add strings together. And so let's look at an example of doing that. This is one operator that's very useful for doing things with strings. We have a couple variables here. We have actually it's a constant named John, another constant called surname, which is Appleseed, and then we create another variable called, or a constant called full name is equal to name plus a space plus surname. And I'm going to go ahead and print this out so that way we can see the result, and it should come out, say, Johnny Appleseed. And so, yeah, there we go. We've got Johnny or John Appleseed. We could change this if we want and say Johnny Appleseed. And notice that it will add Johnny plus a space plus Appleseed. An exercise for you would be to change this stuff around a little bit. Maybe you put something else in here. Let's put a 1 and then that. Let's see what happens. Well, what do you expect it to do? It should say Johnny and then space, a 1, a space, and then Appleseed. So play around with this a little bit, this exercise. Pause the video, see if you put different values in here, what happens. You know, you could even put numbers and things in here if you'd like. It doesn't have to be just letters. It could be numbers too. Rerun it and see what happens. Worst case scenario, you get an error. You've got to undo a few things that you've typed in, you know, erase some of the things that you typed in, or copy and paste it again from the notes. Another thing that you can do is, let's see, let's look at this example. Get rid of this. We paste what we got here, and then we talk about it. Okay, we've got a string here. It's a constant called that contains a value of there. We have a variable instruction that contains the value of look over. And this instruction here is probably new to you. Plus equals in your C-based languages, you will see this. This statement right here is equivalent or is a shorthand for saying this. So this statement and this statement are equivalent. They're the same thing. This is just a shorthand to say that you're adding, you're setting instruction equal to itself plus something else. So what I'm going to do is I'm going to comment this one out, and let's actually comment out this too, and let's print out instruction here. And let me look at this, because instruction, what's going on there? Did I leave something out? Oh yeah, it says look over. So somehow that did not. Okay, That's what it should look like. For some reason that didn't copyright. Maybe I deleted something. Who knows? Also notice here that instruction is spelt wrong, but I'm going to go ahead and run this so that way you can see what the error looks like. Notice here it says use of unresolved identifier instruction, or without the R. So whenever you see unresolved identifier, what it's saying is it doesn't understand what that means. And sometimes it's a typo where you need to fix the typo, or it could be something else, but for some reason it just doesn't understand what that means. So let's say run again. Okay, and it says look over there. So we've got string 2 that's there. Instruction says look over. So instruction, we're setting it equal to itself plus a space plus string 2. Remember, string 2 has there. So instruction is look over, and then we add a space, and then there. We could also, instead of using the plus, there's another way of doing this in Swift. We actually could write it like this. We could say instruction is equal look over, and then there's a function called append where you could add on to the end of instruction a space plus string plus 2. So this instruction here and these two instructions here are equivalent. Most of you will probably want to write it like this because it just kind of makes more sense, but I just want to let you know that this is there just in case for some reason you need to do it this way, which I can't really think of any right away, but I just want you to know that it's a possibility. So to see that these are the same, let's print out instruction. So here this had look over there for the last one that we ran with this print statement. Let's actually, let's do this and let's see what happens. I'm expecting there to be an error. I'll say that ahead of time and I'll explain why in a minute. So the problem here is that it's ambiguous use of instruction. It's just a fancy way to say that you're using the same variable more than once. And so see right there, well, you're not using, you're defining the same variable more than once. Sorry about that. So see, we've got it defined here. We got it defined here. Actually, we can define it differently if we want. Notice this one up here says look over. This says look over 1. You run this, you're going to get the exact same error. What it's saying is, I don't know what to do. The compiler's freaking out. So what you got to do is you can use the same variable more than once. You just can't redefine it. So once you define it, you just remove like that bar off the front there. And if you run it, it should, now this time it should work unless I'm overlooking something. Okay. So this instruction here in this print is the same as doing it this way. Notice that the output is exactly the same. Look over there, look over there. So here we've proved here that we could do it this way. Also, another way is, you know, how I was telling you that this instruction and this instruction is exactly the same thing. I could run this again and show you that we get the exact same output. So that's one way to prove that this way of doing it is the same as this way, and of course, this way. They're all three equivalent ways of adding one or more strings onto another string. Okay, enough about that. Reversing strings. We can reverse the way that reverse a string so that the last character is actually the first character and so on. So I've got a string here that's called, this is a test string. we there's excuse me, there's a function in Swift called reverse that will take a string and will reverse the characters. What you kind of figure to do, and I make this mistake every once in a while, is you may say, hey, I'll use this function here, and then I can just print out what's returned from here and print it out. Well, we can do that, but okay, I haven't spelled this right. B-E-R-S-E-D-C-H, characters, sorry. See, that's one reason why I want to go ahead and kind of run this and let it produce the errors, and then I have to fix them, because that just gives you more exposure to the types of errors and things that the compiler produces. So it says use of unresolved identifier. It means it doesn't know what this means. So I saw that I made a spelling mistake. I left off the S. Let's try running it again. Let's see if things are a little better. Okay, whenever we print out this out, it actually gives us this. It's a weird thing. It says reverse collection string. Okay, right now this is really kind of an advanced thing that we'll talk about later on in the semester. All you need to know is there's another way to fix this, so that way it returns what we want. And the way to do that is to take this reverse strings and type string in front of it. And what it'll do is it'll take this weird thing here and it'll just convert it to a string for us. And so then we can print that out like so. And let me see, did I? Yep, there's another typo there. See, characters, I left out the R that time. And that is probably in your notes as well. And so you may need to fix that. So notice here it spells out this is a string and it says it does it backwards. Now, do we need all of this that's here? Not necessarily. I like breaking it up into smaller pieces so that way it's easier for you to work with. But it is possible to do the same thing by just doing this. String, a string reversed like this. And so this should print the same thing, this string here, twice. So let's run it up. I've got an error. Let's see, what is it complaining about? It's saying expected close parenthesis. Okay, what it's saying is I've left off a parenthesis that I should have here. So let me run this. Okay, and here it produces the result. The first one was this right here where it tells us this weird thing, reverse collection. And then the second print statement is this one here, and here's the third one. So this statement here is a shortcut for these 2 or 3 statements that we've got here. Notice that we take string, and then what's here in reverse characters, we just replace it with what's this a string reversed here. So these 2 statements here are equivalent. So you may want to play around with this a little bit, try different strings, try changing things around a little bit and see what you get. Okay. Let's say that we've got a string and we want to access each character one at a time, each character one at a time. So let's do that here. Let's copy and paste that here. And what I'm going to do is I'm going to replace this with a string. So we're referring to this string right here. And what this should do then is it should print out. Now, this is a statement here that we haven't talked about yet. A for loop, we'll talk about that in a few weeks. I don't expect you to understand everything, but I just want you to know that you could access each variable or each character in the string by doing it this way. So what it'll do is it will print out in this way, THIS space IS. So let's run that. Okay, and that's what it produces. So for right now, I don't expect you to understand really what this is, but just know that this is possible and that sometime in the future, we will be looking at for loops And that's the way to access each character if you need to. Okay, there's times to where you will have an integer of some type of a number, and you will want to be able to convert it to its numeric representation. So for example, let's say, let me comment these out for right now. Actually, I think there's another way you can comment code. You can do it this way with that character, and that'll comment out a full block. So let's say you have a string. A is equal to 1, 2, 3, and you want to say B is equal to 1, 2, 3 as well. And if you add those two numbers together, if they were numbers, integers, you would have 2, 4, 6, right? Should be the result. That's what we're expecting. But what happens if we do A plus B? What happens? Are we going to get 2, 4, 6? I don't think so. Let's see what results. Oh, well, these are strings. So the add operator acts differently on strings. It actually appends it onto one another. What we're wanting here is A to equal 1, 2, 3 as an integer, not as a string, like so. Now, if we print this out, we'll get the 2, 4, 6 that we're expecting. So realize here that these aren't the same. If you let A equal an integer and you try to add integers together, it does the regular math. If you've got strings, it appends one string onto another. You may say, well, what about if we have something like this? 1, 2, 3, or A plus 1, 2, 3. What's going to happen? I think this is going to produce an error. Yes, and the reason why is it says that the plus operator cannot be applied to an integer and a string. It doesn't know how to do that arithmetic. Do you know how to do that arithmetic? Because really what you've got is 1, 2, 3 plus a string 1, 2, 3. How do you add those together? I don't know. It's not defined. In some languages, you could actually define what that means, and that's something you may learn later on in some of your courses. But what we've got now, there's no way to do that. So let's look at this here below, what we started with here. 1, 2, 3. What it will do is it will take this string 1, 2, 3, and it will convert it to its integer counterpart, which is 1, 2, 3. So this print statement up here, if we would actually do A plus int of 1, 2, 3, what will it do? Okay, this is some advanced stuff here. Let me see. I think we could put that operator there and it will work. Plus using, okay, we need a double one of those. Okay, I think that's right. Nope, that's not right either. Okay, default contains nil. Okay. This is where things get a little funky because what is going on here is that it's saying that it wants to be extremely careful. It says, well, what about if something happens where 1, 2, 3 cannot be converted to an integer? And that's true. Let's do this and let's see what happens. Cannot use optional chaining type int. So what this does, error, doesn't know what to do if this isn't right. See what that does. Okay, it gives us the same error. Down here, it actually, really what this is it's a bunch of warnings. If you look down here at the bottom, it actually does produce the value of 1, 2, 3. It's called an optional. What it means is that there's a possibility that this value here may or may not be a true integer type. Okay, we're getting some, okay, has November. Okay, I'm getting this confused with the different language. So this is part of what goes on whenever you try to do something live. Sometimes things work, sometimes they don't. But as you can see here, as I'm messing around with stuff, you see some of the errors we get down here. Whenever we run the assembly, we get nil or null. And the reason for that is because the int here, whenever it looks at the ABCD, it doesn't know how to convert that to an integer. So it returns with a null. Notice that we have other types here. We have doubles that we can do the same thing. Let's do this one first. Yeah, so it says an optional of 10. I'm going to have to look that up exactly how to do that. So let's move on to the next topic. And like I said, I'll put another part on here to clarify what some of those things are. But I'm going to leave the things that I've done because you will yourself run into those types of issues and you'll need to figure out how to resolve those as well. So I see that as being a good learning experience. And so I am going to leave that stuff in there, lowercase. So sometimes whenever we have characters, we'll want to uppercase everything or lowercase things because we may not know exactly how the input's coming in and we want to normalize it somehow. And so what happens here is we'll take this text and we will uppercase it, and then we'll also lowercase it, and we're placing it into these constants here, and then we're printing it out. So whenever we do that, the first one uppercases the values like what we see, then the next one lowercases it. What I'm going to do here is I'm also going to print out text just to be able to show all three of them side by side or one on top of each other. So we have here the original text. Here's all the values uppercase. Here's all the values lowercase. It's possible to do this directly in here if you would like. So we could do text uppercased, past tense. Most of your languages that I've seen has uppercase and not with the D on the end, but Swift does it with a D for like past tense. For some reason, that's the way they decided to do it. So by changing this, we should get two uppercase ones, and then the last one will be all lowercase. Let's rerun that. As you can see, that's what we got. So that's how you uppercase all letters, and that's how you lowercase all letters in a string. Another thing that's really neat about Swift, and I kind of like about the language, is that you can put variables in with your strings. What you've seen me do at sometimes is actually, in some of my examples, is I will have something like this, and then I'll make a comma, and then a variable or something. And so let me run that. You'll see blah, but it's possible to do something like this. So whenever you do this, you do the backward slash and then put uppercase inside here. It knows to not take the literal what we see here, but it knows to substitute this variable in for this value here. And so this statement on line 8 and this statement on line 9 are equivalent. So let's see that as you see there. So that's a neat thing that you can do. If you prefer this way, that's how a lot of languages do it, that's fine, but I want to let you know that this is a possibility, so you may want to do that in some of your code or be able to understand what it means. Of course, I'm not going to tell you you have to do it one way or the other, but just be able to look at both of these and know that they are equivalent. So if we look at the notes here, let me copy and paste some of this here. Okay, get rid of this, paste this. This is just a line of text, so I'm going to comment that out. But here we have let number equal 5, and then we have another constant where we're setting it equal to the string of 5, because we're just going to take the value of number here, place it in here, and then we're going to create another variable where we actually have a string here with, you can also do a calculation here. You don't just have to use variables, you could actually have numbers in here as well. And this will be equal to the string of 42. And so these two print statements here should be equivalent, showing you that these two produce the same result. So let's see that. So there you go. 6 times 7 is 42. The first one is written this way. And the second example is written using the variable. So you could do it either way, however you want to do it. You could also do it like this. I'm just going to put a 1 so it's different. 6 times 7. And then whenever you're down here, do it this way. The only difference is that 42, the first one here, is a string. Notice the double quotes on both ends. This is actually an integer, 6 times 7, but it will do the substitution that's here. So we do this, we should get 3 lines that says the same thing. Because what the print statement does, it'll take whatever's here, and this will end up being a string whenever it's done. So as you notice there you go, there's 3 42s. So there you go. That's this week's lecture notes. I will try to post something onto the end here with a couple of those complications that we had, so that way you guys know how to resolve that. I had to do a little bit of reviewing on it because it's actually been a little while, and I use some other programming languages that do the same kind of thing, and the way each of them handles it is slightly different. What we're dealing here is actually a little bit more of an advanced topic called optionals, which what it means is just a way to deal with your code if something bad happens. Like, for example, right here we look at this. We know how to convert 1, 2, 3 to an integer. The string 1, 2, 3, well, that's easy. It returns, it should be 123. But what do we do in a situation like this? We could get user input instead of typing in a number, they could type in something funky, or they accidentally type something wrong. And how do you deal with it? So let's look at this example. In most cases, I'm going to kind of play nice with you guys with the Swift compiler. I'm not going to expect you to do a lot of weird, funky things all the time, but you know, unless I tell you that you got to look for that as a possibility. So let's look at these two examples. Let's run this and see what happens. Actually, in this case, everything that we have here, up here at the top, these are just warnings. They're just telling us, hey, the compiler is saying you're doing something that's making me uncomfortable. It's making me uneasy. If you notice here, it goes ahead and runs it anyways, and it outputs a result. And what this does, whenever we just output X, it returns this optional 1, 2, 3. And what it means, the optional, it just means that this may be good input, or it may not be. The compiler doesn't know. It's up to us as the user to figure out if this is good data or not. So that's what happens with this print statement. It prints out the optional. If we want to go ahead and get the data inside there, we can put an exclamation point at the end of it here to say, give me whatever is that optional. So in this case, it'd be a value of 1, 2, 3. Let's go ahead and print that or execute that. Notice here we get X equal to 1, 2, 3 for this statement here. So we can then use that value. Later on, whenever we talk about if statements and about decision making in our program, we could actually do something with that value to check it to make sure that it is a valid number. Right now, that's beyond the scope of what we're doing here. And let's print out, let's look to see what happens whenever we try to print out. Let me also put here print y equals, and then just y, and let's see what happens. Of course, we get all of these messy little warnings up here at the top, but if you look down here at the bottom, we get our optional 1, 2, 3, which goes for this print statement. The 1, 2, 3 for the exclamation point, and then for the y, we get a null value. Later on, whenever we got if statements, we'll be able to check to see if y is equal to this value of null. If it does, then we know that the output is invalid. Otherwise, we could go ahead and do this to get our value. Like I said, right now, this is beyond the scope of this program, of where we are in this class. Unfortunately, Swift has made this very complicated, more complicated than what it probably needs to be at this place. But I want you guys just to know that there are ways to convert from a string of numbers to an integer, and we'll look at this a little bit later. Whenever we talk about if statements and be able to change the flow in our programs, we'll come back and visit this and know how to deal with it. But right now, I just want you guys to know that this is a little bit complicated, and if you run into issues like this, you know, sometimes Google some of the messages, some of the error messages, and see what happens. What I did was I Googled it, and I come up with something like this. This page here on Swift Optionals on the programiz.com website. It went through and explained some of that to me on how it works. I recommend that you guys go through this and kind of read what it says. Do a Google search on Swift Optionals, which I just use Swift Optionals. Actually, I use DuckDuckGo, and this is the link here. Other websites will give you something similar. And so with being a programmer, you've got to experiment a little bit, see what works, what doesn't work, see what the compiler expects, and go with it. Because guess what? The next version of the compiler, it possibly could deal with this stuff a little bit differently. And usually they put out notes explaining that, how things change, and then you have to go into your code sometimes and change things around. But I just want to let you guys know that this is somewhat common from time to time, that a language will change how things work a little bit, and then you've got to adjust your code for that.